Okay. Now this circle now is what we call, I'm going to put here, our XZ plane. And once again, it is our plane. Okay. So when this is the case, okay, why we call it YZ plane? Because point X, right, to the principal stress, right, this angle again is acute, right, less than 90 degrees to the principal stress. So we call this our XZ plane. Okay. So the purpose of doing this is to also determine determine the plane of the maximum shear stress is acting on. Okay. So for this case, right, the maximum shear stress, so we have three circles. Okay, which one will generate the maximum shear stress is the in-plane one. Okay, so we know that this distance from here to here, right, the in-plane, right, this is our tau max, which is equal to the shear max in your what, XY plane, right, which is also your in-plane. Okay. So this is how we construct 3D Mohr circle. Okay, as I said, constructing the circle is really easy. What it actually means, okay, or how you actually use it is more challenging than anything else. Okay, so let me quickly recap. Constructing 3D Mohr circle is very straightforward, as you can see, right? No changes in terms. You can construct it from 2D Mohr circle principle. The thing you have to know is what does those three circles means. What do I mean by that? You have to know which circle is your XY plane, which circle is your YZ plane, and which circle is your ZX plane. Okay, so now there will be three conditions. Okay, before I talk about the three condition, okay, as I said, the purpose of using 3D Mohr circle is to determine the plane of maximum shear stress is acting on. Okay, that is the key objective. Okay, I understand that you will not know why that is so critical. Okay, I'll show you some examples now. Okay, so we're going to look at conditions now. Okay, we're going to look at condition. Before I go on, anyone, any question? Anyone? Okay, I hear nothing means you all are fine. So let's look at condition number one. So condition number one is we have stress X is greater than stress Y. Both are positive. Right? And not comma, I do apologize, and stress Z is equal to 0. Okay. So sometimes some of you might say, Eugene, if stress Z is equal to 0, can we just do 2D Mohr circle? Okay. So what I'm going to do is we're going to solve this just by doing 2D. Okay. And then we're going to solve it using 3D. Okay. Let me elaborate what I mean now. So let's say now we have we draw a 2D element. Okay. And we're going to relate to 3D. So this is our X and this is our Y. So we are just going to do 2D Mohr circles. Analyze the structure with the 2D Mohr circle. Okay. So stress X is equal to 60. Stress Y is equal to 30 MPa. Okay. In 3D, okay, in 3D, so now I'm going to construct this in 3D. So this is our X, Y, and this is our Z. Okay. Then I'm going to draw 3D. Okay. So we have a 3D. So this is 60. This is 30 megapascal. Okay. So on 2D, this is our point X. This is our point Y on Mohr circle. So this surface over here is point X. This is our point Y. And this is our point Z. Okay. So the objective I'm trying to show down here is why is it critical to analyze this structure or any structure using 3D Mohr circle. Okay. And I hope this will create a good example. Okay. So now we construct the Mohr circle now. Okay. So all these have no shearing stress, right? They are all the principal stresses. So this will be our 0, 10, 20, 30, 40, 50, 60 normal stress. And then we have our shearing stress. Then 20, 30, 40, minus 10, minus 20, minus 30, minus 40. Shearing stress, element rotate clockwise, element rotate anti-clockwise. So we know that our normal stress X is at 69. So I'm going to draw a 69. Let's do 2D first, okay? So this is our stress X. And then our stress Y is at 39. Okay. This is stress Y. So they have 0 shearing stress. So this is your point X. And this is your point Y. Okay. And then from here, we can construct our 2D Mohr circle. So this is just constructing 2D Mohr circle. And this belongs to our X, Y plate. This is our in plate. Okay, that's our in plate. So if you use 2D Mohr circle, right? When you calculate your maximum shear stress will have this value. Okay, so we look at maximum shearing stress. So our tau max in the XY plane is equal to 15 megapascal, as you can see now, right? And we realize that this is just using 2D, okay? One circle, we know that, okay? And in 2D Mohr circle, if you look at 2D Mohr circle, our stress max is equal to 60 megapascal. Our shear max is equal to 15 megapascal. Okay, fine. Okay. So now when we use 3D Mohr circle, right, we know that point Z will be over here, because point Z have 0 normal stress and 0 shearing stress. Then we have to draw another 2 more circles. Okay. So the next circle that we're going to draw, and some of you might say this circle might not be very significant, and you're right. Right. So this is the next circle. Right. And this happens to belongs to the YZ plane. And this is our out of plane. And on your YZ plane, you realize that your stress max is equal to 30 megapascal. Shear max is equal to 15 megapascal. Right? No problem. Okay. Now the issue comes is when we draw the third circle. Okay, so we're going to draw the third circle now. And I should not have chose 3060. Okay, I should have chose some other numbers, but this is okay. This is the third circle. Right. And this third circle over here belongs to your XZ plane. Okay. And what you realize about the XZ plane, okay, the stress max is still what, 60 megapascal, but your tau max is now equal to what? 30 megapascal, the largest. Okay, so now we draw a line here. So this is your tau max now. Okay, your tau max in your XZ, right, is equal to 30 megapascal. Now, what is interesting now is the 30 megapascal is your what? Out of plane. And this is your overall tau max. Okay. So if you were to just use 2D Mohr circle to solve this problem, okay, you are only going to be able to find 15 megapascal. Okay. So if you were to analyze using 3D Mohr circle, then you are able to compute the what? 30 megapascal. The stress max does not matter because the stress maximum is either use 2D or 3D is still what? 60 megapascal. But the tau max value changed to 30 megapascal. And it's why this is important, because material, the shear stress in general, in general, you know, in general, the material shear stress or shear strength is lower than normal strength or normal than normal strength.